Let's start off with the next type of integrals, and again, these are the ones in which we will use substitution formula to derive them. So we'll write the direct formula, and in the books you'll get the direct formula, but we'll try and derive one of them. So let's say you have integration of 1 upon x square plus a square dx. The formula for this is 1 by a tan inverse x by a plus c. So this is the formula. Now let's see how we can derive it. So let's see one of the derivations and then we'll write down all the formulas. So this is one of them. Let's derive it. So if I want to derive this, what I'll do is uh, in integration, what we do is we should remember some substitution. So see, this is x square plus a square, right? So what we'll do is in this case, in integration, what we do is if we have something like x square plus a square, so like something like this, let's say root or without the root. Let's say if you have x square plus a square. So we'll try to put x is equal to a tan theta or x is equal to a cot theta. And the reason is because 1 plus tan square is sec square and 1 plus cot square is cosec square. So that's the logic. This is for if you have x square plus a square. Now let's say if you have something like a square minus x square. So in this case what we do is we put x is equal to a sine theta or x is equal to a cos theta. And the reason is because 1 minus sine square is cos square and 1 minus cos square is sine square. This is again one of them. And the third is if you have something like this. If you have x square minus a square. In this case you put x is equal to a sec theta or x is equal to a cosec theta. Okay. Now the reason here is because 1 plus tan square is sec square. So sec square minus 1 is tan square. So that's the basic idea because here you'll have, if you put x as a sec theta, you'll have a sec square minus a square, right? So these are the three types which we should remember in order to derive these formulas. Obviously in exams or in even in JE, you don't need to derive them. You just need to remember the formulas. But let's do one of the derivations just to get a hang of it. So let's say if you want to derive this one. So what I'll do is let's do it on this page only so that we get a better idea. So okay, so what we are doing is we are using substitution. We are putting x is equal to a tan theta, and what we'll do is we'll put tan theta. We'll write tan theta as x upon a. Now I can say theta is tan inverse x by a, right? Now what we do is once we substitute, what we do is we take derivative on both sides. So in this case what I'll do is if I take derivative on both sides, I'll have dx is equal to a sec square theta d theta, right? Now let's substitute in the integral. So we have I is equal to integration of, for dx I'll write a sec square theta d theta, and for x square, for x we are writing a tan theta, so this will be a tan theta the whole square plus a square, right? We got this. Now let's see the magic. What will happen is here you'll have a sec square theta d theta, and here see what you get. You get a square common, so a square common, and you have tan square theta plus 1. So what you get is 1 plus tan square is sec square. So see, this gets cancelled and this will be 1 upon a. So I have 1 upon a integration 1 d theta. Integration of 1 is theta, so this will be theta upon a plus c, right? And theta is what? So we know theta, so this is 1 by a tan inverse x by a plus c, right? So this is the formula. which we'll remember. This is just derivation in case you wanted to know how to derive it. So this was the first one in this type, and in total there are around seven of them. So let's write down all the formulas. Dx upon a square minus x square, this is equal to 1 by 2a log a plus x, a minus x plus c. The third one is integration of 1 upon, you can write 1 upon or dx upon, so 1 upon x square minus a square dx is equal to 1 by 2a x, 1 by 2a, then you have log x minus a x plus a plus c. This is the third one. Let's try the fourth one. Fourth one is integration of 1 upon root of a square minus x square dx is equal to sine inverse x by a plus c. The fifth one, integration of 1 upon root of x square plus a square dx is equal to log of x plus root of x square plus a square plus c. The sixth one, so let's write it here. Sixth one, integration of 1 upon root of x square minus a square dx is equal to log of x plus root of x square minus a square plus c. And the last one, 1 upon integration of 1 upon x root of x square minus a square dx is equal to 1 by a sec inverse x by a plus c. And also let's write the first one here so that we have every formula on the same page. So that was 1 upon x square plus a square dx is equal to 1 by a tan inverse x by a plus c. Now with experience, the important ones are this one, the first one. So you can just remember this is 1 upon x square plus a square. Now see, a square can be anything. A can be 4. So this can be x square plus 16. This can be x square plus 25. So you just have to, you know, check the sum and compare it with these formulas. It will be 1 upon something and you have to compare with these formulas. So with the order of importance, so this one is important. This one is important. Rest can also come. However, this one the sums based on these this formula are very less, so you can just say not very important, right? Rest we just have to check. See, if you check, this is 1 upon a square minus x square, so then you have 1 by 2a. This is x square minus a square, so almost similar formulas, just they have to make the changes in the sign. Now this is in root. So for root you have this one, you have this one, and this one are in roots. So just have to compare it with the formula. So let's do few sums and see if we are able to compare it with the formulas. So let's start off with the first one. So let's say the first question is find integration of 1 upon x square plus 8 dx. Let's solve this. So now if I see, it's 1 upon x square plus a square, so this part is actually a square, so I can just write this as, this is integration of 1 upon x square plus 2 root 2 square dx, right? So this is a, so what is the formula? 1 by a, so that is 1 by 2 root 2 tan inverse x upon 2 root 2 plus c. So this was the first question. Let's try one more. Let's say we have integration of 1 upon 9x square minus 8 dx. Let's solve this one. Now This doesn't look like a standard form, so what I'll do is I'll take 9 outside, so I can write this as x square minus 8 by 9, and I can take 9 common, right? Very simple thing, just taking it common. Now I can write this as 1 by 9, 1 upon x square minus 2 root 2 by 3, the whole square dx. Now this is 1 upon x square minus a square. So you can just compare the formula. So let's see which formula is this. So you can see clearly see the third one, right? 1 upon x. So what is the formula? 1 by 2 a log of x minus a, x plus a. So let's, so this would be 1 by 9. So see, 1 by 9 is outside. 1 upon 2a. So 2 into a, which is 2 root 2 by 3 into log x minus a. So x minus 2 root 2 by 3 upon x plus 2 root 2 by 3 plus c. And then you can simplify, you can take LCM, you can cancel out things. So that is fine. But this is the final answer. Mostly this is the answer. If you want, you can just do one more step, and let's do it. If you do one more step, so this is 3 threes are, this is 6, and this is 12. So this is 1 12 root 2 log of, and let's take the LCM here. So you have 3x minus 2 root 2 upon 3x plus 2 root 2 plus c. So this is the answer, right? Let's try a few questions where you have root. So now you know how to compare, you just have to compare the formulas, and that's it. That's it. So let's do one more. So let's say you have 1 upon root of 9 minus 16x square. So see, whenever the coefficient of x square is not 1, so in that case, you will just try taking common, so that the coefficient of x square becomes 1. So let's solve this one. So let's take 16 out. So we'll have 1 upon, let's write this way. Let's take 16 here. So we have 9 upon 16 minus x square. So hope you understanding how I'm taking common. And 16 I can take out because square root of 16. So that's 1 by 4. So now this will be 1 upon root. Now this will be 3 by 4 the whole square minus x square dx. So now this is 1 upon root of a square minus x square. Now this is the easiest formula. So the simplest formula. So this is 1 by 4. The formula is sine inverse x by a. So x is what? X is x in this case, and a is 3 by 4 plus c. So what you get is 1 by 4 sine inverse 4x upon 3 plus c. So do remember these 7 formulas, and remember it is 1 upon x square minus a square, or 1 upon a square minus x square, or 1 upon root of a square minus x square, or 1 upon root of x square minus a square. So mostly these will be the sums, and you just have to take care of the signs and apply the correct formula and get the answer. So till my next video, please take care. Bye bye.